things under microprocessors. First of all, we looked at the purpose of the microprocessor in a computer system, as being it one of the major components as well in the computer system. And its core purpose is to actually process data into information, okay? That is basically transferred or inputted from input device to the RAM and then basically to the microprocessor. Now, today we're going to go step by step with the help of a PPT so that we can then identify more what the microprocessor does, all right? So we are basically going to look at how the microprocessor executes programs, and then also look at some Boolean logics, and then binary circuitries. How do they help in the microprocessor? So quickly, let's then define some of the major components that are found in the microprocessor that enables it to function the way it does. So we are saying that the microprocessor carries out the program's instructions, okay, which are operated on. And basically, most of these programs are in form of data, which is then loaded into the computer memories. All right, and then we also say that the microprocessor is further referred to that there are different types of microprocessors that we may also look at. But the one that we're concentrating on, since we are looking at the type of digital computer, which is a personal computer in this case, we are talking about something known as the microprocessor, and it includes all binary circuitries that carry out arithmetic and logical operations, okay? Now, all these circuitries, so we can define probably the word circuit. The word circuit is a complete path where electricity flows, okay? So a complete path of charge is what a circuit is. And these circuitries are divided in different components, as well, like we're going to see later on. Now, some of these circuitries are basically involved in carrying out arithmetics and logical operations. And most of these circuitries in the microprocessor are further reduced into a single integrated circuit, okay, which is an IC. And then, the CPU itself is further subdivided into 4 key major components, okay, which we are going to examine one by one. Number 1 is something known as the control unit, right? So in the microprocessor, there's something known as a control unit. And then we have something also referred to as the arithmetic and logic unit. And then we have as well something known as registers and the clock, right? And also, we may also not include wires there, which are referred to as buses or internal buses. These are key connectors, okay, that connects these 4 major components in a microprocessor. And remember that these components are circuitries, so they have to transmit a signal at some point. So for them to do that, they have to use this set of wires to transmit those signals to and from the components themselves, that is source to destination, all right? So then let's propound on each and every component. What does it do then? Control unit. The control unit, this is a circuit responsible for coordinating machine activities. What do we mean when we say machine activities? So it controls a sequence of operations, okay, in the microprocessor itself, all right? Remember, the microprocessor is a unit, or the other name of the microprocessor is referred to as the CPU, Central Processing Unit. Now, in that same unit, all right, that is responsible for executing data, there is that subcomponent that we're referring to as a control unit. So the core function of the control unit is to basically control sequences of operations. But we have to identify what type of these operations. We're going to look at them later. So another subcomponent that we have is the arithmetic and logic unit. And what does it do as well? This is a circuitry that is used to perform data manipulation, okay? It is used to perform data manipulations with the help of arithmetics and logical operations as well. All right. And when we say arithmetics, we're basically talking about plus, addition, division. So those operations are basically used to manipulate the data that is supposed to be worked on by the microprocessor itself. And then when you say logical operations, we're basically talking about comparisons. All right. Logical operations are basically talking about the and, or, not. Okay. Those are logical operations that are involved. All right. In summary, that is about the arithmetic and logic unit. What about registers? So we're saying registers, these are temporal storage areas in a microprocessor. And the function of them is actually to hold information applicable to the current operations. So there are different types of registers, which we're going to look at when we narrow down just the registers. And what is their co-function in the microprocessor, all right? What is their co-function in the microprocessor? Clock. What does a clock do? What does a clock do in the microprocessor? So its job is to trigger, start and stop of all CPU operations. Now remember, we said the control unit, its function is to control sequences of operations. But what triggers them and stops them in the microprocessor is something known as the clock. And normally the clock is referred to be the heartbeat of the microprocessor. And what we mean by that is that if it's beating, then it simply means that there's basically operations that are running. And then if it stops beating, it basically means that the operations are no longer in execution, all right? So that is what the clock does. Now, if you look at the diagram below there, you find that some of these two key major components like the CU and the ALU have basically been featured, and this is how they are aligned in a sketch of the CPU itself. And we can also see the clock there at the bottom, all right? Now, in brief, I'll just talk about what instructions the CPU typically looks at in terms of category. So the instructions that we're talking about here, or the data that we're talking about in the microprocessor, they are basically categorized in three instruction sets. Okay, we call them instruction sets. So the category is that the instructions that are responsible for loading data, storing data, and copying data, they're categorized in a category of data movement, all right? So the CPU supports data movement and all instructions involved in data movement, like loading of data, storing of data, copying of data, all those are loaded in that particular category. And then the CPU as well supports instructions that fall in a category of arithmetics and logical operations. So we're talking about, when we say arithmetics, we're talking about addition, subtraction, comparisons, okay? So all those instructions like add, subtract, compare, they're instructions that the CPU itself recognizes under arithmetics and logics, okay? And then the other category of instructions that the CPU recognizes is the program control instructions, like branch ought, for instance. Those are instructions that are controlled or observed by the microprocessor itself. So in brief, we are saying that these particular commands, okay, they're executed by the CPU and they're in a logical structure, all right? They're in a logical structure. They come in form of logical structures, which is a software, all right? And then these commands are implemented as electronic binary circuits, because remember, the components that we mentioned earlier, like the CU, the arithmetic logic unit, and so on and so forth, those are electronic circuitries. They're basically made of hardware and they have to transmit binaries, which is zeros and ones. All right. So for these instructions to be recognized, they have to be transmitted in form of zeros and ones. Okay. Forming a physical structure of it, forming a physical structure of those things. All right. That is very important to understand. That is very important to understand. So then, the basic instruction set of, of the microprocessor with the three categories that we have looked at. We have understood that actually the basic instruction set of a microprocessor is in category of data movement, is in category of program control, and is in category of arithmetic and logical instructions, all right? And these are some of the basic instruction set that sample or partial of these basic instructions that the microprocessor does recognize, like the word STO, all right? Those acronyms. And STO is an instruction that the microprocessor recognizes for storing data in a particular location of memory, for instance. The add, okay? And this particular instruction will be used by the microprocessor to add two different values, okay? Two different numbers together, all right? That is a basic instruction. Sub, which will subtract one or two numbers from another, all right? And then mul, which will stand for multiply, and this, it can be used within the basic instruction to multiply two values. Div, divide two numbers, inc, which is increment two values by adding a one, okay, which is an increment operator. And then compare, you can compare two values using what we call comparison operators, all right? And then jump, it can jump from a specific position of a value to another in an instruction code using what we call arrays or indexes. So these are some of the basic instruction sets that the microprocessor does recognize within itself in order for it to perform, okay, its core function, which is to process data. It has to apply some of these basic instructions to do that, all right? So in what form, apart from these circuitries having to encode these instructions in zeros and ones at physical structure level. So in what form do instructions really come in or are given to the microprocessor? So instructions are basically given in a form of a program, okay? So they're given in a form of a program, which we defined earlier to say a program is a set of well-organized instructions, okay? Written down by either a programmer or you people. And one of them is, for instance, this Zoom you're using. That is a program, all right? And it's a software in this case, okay? So you're saying, so it knows when this particular program comes in and switches on, it knows which particular circuitry within itself it's supposed to utilize in order to process or to execute, in this case, this type of program, so that you later on you see the results being encoded in different output devices. So like I said earlier, we say a program consists of a sequence of instructions. So each instruction specifies both the following things. So these sequences of instructions, they specify two things, all right, in order for them to fit within an instruction set of the microprocessor. They specify the operation to be performed, all right, number one, and then they also specify the address of data it will transform into that particular operation, okay, if necessary, all right, if necessary. So in the microprocessor, specifically within the registers, in what form are these same instructions stored, okay, which is these programs or these operations and devices stored? They are stored in a machine language, which is normally referred to as a microcode, all right, which is referred to as a microcode. We're not going to dive much into some of these technologies because we're basically just doing the program on the surface. But if we were to dive much into those, they even become more complex as we try to envelop them, all right? So then, now that we know the instruction sets involved in these components. Let's look at registers. Okay, let's look at registers. It's one of the key memories of the microprocessor. All right, registers basically they're the fastest and smallest memory in a computer system, and they're normally used by the microprocessor. But basically, there are two categories of registers. Okay, in this case, we're talking about special purpose registers and general purpose registers. So, general purpose register is basically used to store any of the two sets of operations that we talked about, instructions that we talked about, which can either be the operation status or the operation itself and the addresses of this particular, the destination and source component to where these instructions are supposed to go to within the microprocessor, all right? So, but for special purpose registers, they're specific. They can either store addresses, they can either store status of the process. In this case, when we say process, we are referring to a running program, a program that is already running. Like right now, we're using Zoom. So Zoom right now is being declared to be a running process, and it has to be sustained by giving it resources, all right, in a computer system. So then we're going to look at some of the few key special purpose registers, because there are different types of special purpose registers in a computer system that store different things, all right, in the microprocessor. So one of the special purpose register that is found in a computer in the CPU is something referred to as the program counter, right? Now, the program counter is normally also referred to as a stack pointer, right? The reason as to why it's referred to like that, because it stores the address of the next instruction to be executed in the microprocessor, all right? So let's give an example. We may say, currently the microprocessor is running Zoom, for instance. It's currently executing Zoom. And then we have a queue of other software programs to be executed, like you have opened up MS Office, you have opened up VLC. All those, they have to be attended to. Now, where are all these going to be loaded into first and foremost before you initiate a system call? They're going to be loaded into what we call the RAM, okay? They're going to be loaded into what we call the RAM. So we're saying that the CPU normally interacts with the main memory form, RAM, because that's where all instructions that are going to be executed by the CPU itself and that have been executed by the CPU itself are loaded into, okay? This is why the RAM and ROM, normally they're referred to as main memories or primary memories. So the key one is RAM, okay, that we're discussing about now. So the RAM itself is subdivided into two columns, okay? We may give that illustration. We may say the RAM is divided into two columns, one that sells for addresses and then sells for the actual instructions that are about to execute, all right? So then the question is that how then do we get to work on a specific instruction from the RAM? How does the CPU does the identification of which instruction to work on from the RAM specifically? So what the CPU does is that it then identifies which address of the next instruction that the stack pointer or the program counter has pointed to. Are we together? That's where actually the term stack pointer comes in, because it points to the next instruction to be executed or worked on. All right. So what this does is that in operation, the program counter, all it does is that it increments the value of the address that it's keeping. When we say increment, it basically adds a 1 to the address that is basically stored in the program counter itself, so that it points to the next instruction that is coming in. So by virtue of it adding a 1, then automatically we are referencing to the main memory, which is RAM, and already pointing to a cell whose value is now indicated in the program counter. So then after it does that, We also have another type of register, all right, away from the program counter. Remember just that the program counter or instruction pointer, stack pointer, its core function is to store addresses of the next instruction to be executed. How does it do that? It's by incrementing the current address it has so that it points to the next address in the main memory. All right. So we have also something referred to as the instruction register. So we have also something referred to as the instruction register. Now, what does the instruction register do? It's a special purpose register, just like the program counter. What it does is that the instruction register stores the current instruction being executed by the CPU. So we're assuming that the program counter, as the instruction register is storing, for instance, the operands of Zoom, then what the program counter would do is it will increment the address of the operation of Zoom, which is currently being executed, so that it points to the next instruction. So the core function of the instruction register is just to store the current instruction being executed. All right. So I think we'll end here for today. The next time we'll come and meet.